Hello viewers, I am Kausalya. Today we are going to solve problem number 4 under exercise 9.1. The problem is the angle of elevation of the top of a tower from a point on the ground, right? Let this be your tower, right? And from a point on the ground, okay, there is a point, angle of elevation, okay, we are looking upwards, right? It is given by 30 degree, right, which is 30-meter away from the foot of the tower. So here the thing is, you see there is a tower and there is a point on the ground, right? So the angle of elevation of the top of a tower from a point on the ground is 30 degrees, right? Then which is, what do you mean by which here? The point, right? The point is 30-meter away from the foot of the tower. So this is your tower and this is your foot, and this point on the ground is 30-meter away from the foot of the tower, right? We have to find the height of the tower here. So in this case, you see, from this triangle, wait, okay, the same thing I have drawn in a better way. So from this triangle, we need to find AB. So what is AB here? To this angle, AB is your opposite side, and we already know the value of adjacent side. So what is the formula we can use? We can make use of tan, right? So you see, tan 30 degree is equal to, this is AB by BC, right? What is the value of tan 30? It is 1 by root 3. And what is the value of, that is AB remains as such, and what is the value of BC? Here it is 30, right? So just cross multiply, 1 into 30 is 30 and root 3 into AB. We need AB, right? Therefore AB is nothing but 30 divided by root 3, right? So 30 can be written as 3 into 10, right? So here you may ask, why can't we write it as 15 into 2? Yeah, that is also correct. But you see, what is the number we have in the denominator? We have 3, right? Therefore, we need to split this 30 in terms of 3, right? So 30 can be written as 3 into 10, right? So here again, 3 can be written as root 3 into root 3, right? Here this 10 as such and divided by this root 3. So now this root 3 cancels each other, and here the final answer is 10 root 3 meter. Right. So here the height of the tower AB is 10 root 3 meter. So this is the simplest method to solve this. Right. But here what I have did is, you see, I have calculated, I had made use of cos 30 degree. Right. So cos 30 is nothing but adjacent side by hypotenuse. So here adjacent is BC and hypotenuse is AC. Right. So just substitute the values. The value of cos 30 degree is nothing but, this is root 3 by 2 and BC is 30, right? So again do a cross multiplication. So root 3 into AC is equal to 2 into 30. So now we have calculated the value of AC, right? So 2 into 30 is 60, and this root 3, when it is brought to the right hand side, it occupies the denominator part. So here it is 60 by root 3. Right. So actually this is the lengthiest step, okay? Lengthiest process. You don't need to go by this method. The simplest way is making use of tan degrees. But here I had made this to show in whatever method you solve the problem, you will be getting the same answer, right? So now we have calculated the value of AC, right? So here in this diagram, what is your AC? AC is nothing but your hypotenuse, right? So what we need to calculate? We need to find the value of AB. Right. So now I am going to consider sine 30 degree, because sine 30 is nothing but AB by BC. Right. So sine 30 is equal to AB by AC. So here sine 30 is 1 by 2. And what is the value of AC? It is 60 by root 3. Right. So here the thing is, now again we are doing a cross multiplication. So 1 into 60 by root 3 is 60 by root 3 and 2 into AB. Right. So 2 into AB is equal to 60 by root 3. And what we need to find? We need AB. Right. So AB is nothing but 60 by root 3 into 2. Here it is in numerator part. So here it occupies the denominator part. So again 2 and 60 get cancelled. The answer is 30 by root 3. Just for our simplification, we are writing this 30 as 3 into 10 divided by root 3. Again the same thing. 3 is written as root 3 into root 3 here. And finally, the answer is 10 root 3 meter. Right. So in both the cases, you see the answer is same. Right. And it is up to you to select which method to go. Right. So now we move on to problem number 5. Right. A kite is flying at a height of 60 meter above the ground. So there is a kite, right? It is flying 60 meter above the ground. That is from the ground. The kite is at a height of 60 meter, right? The string attached to the kite is temporarily tied to a point on the ground. Okay. The string, okay, you know, right? Kite will be having a string. So here the string is, okay, it is tied to a point somewhere on the ground. Right. So the inclination of the string with the ground is 60 degrees. So the angle, okay, the string that makes with the ground is 60 degrees. So find the length of the string, assuming that there is no slack in the string. So what do you mean by slack here? That is the rope is stretched, okay. There is no sag. There is no dip, okay. The rope is held straight. That is just like a straight line. The rope is very stiff. That is the meaning. So find the length of the string, right? So what is the length of the string? From this diagram you see here, this is your length of the string, right? So from a triangle point of view, the side AB is nothing but your hypotenuse, right? Yes. So we know the value of opposite side, right? And we have to find the hypotenuse. So what is the formula we can make use of? We can make use of sine 60 degree. So sine 60 degree is nothing but opposite by hypotenuse, and here it is AC by AB. Right. So just substitute the value. The value of sine 60 is root 3 by 2 and the value of AC is 60. Right. Again just do cross multiplication. So root 3 into AB is equal to 2 into 60. So again to find AB, just move this root 3 this side. So here it is in the numerator part. So whenever it is moved on, it occupies the denominator part, right? So again, 60 can be written as, because in the denominator I am having 3, right? So just split 60 in terms of 3, right? So if you don't know, just divide it like this. 60 divided by 3 gives you 20. So 60 can be written as 3 into 20, right? So here it is 3 into 20 divided by root 3. So again this 3 can be written as root 3 into root 3, right? Now this root 3 and this root 3 get cancelled, and finally we are having 2 into 20 into root 3. So 2 into 20 is nothing but 40. So here the final answer is 40 root 3 meter. That is the length of the string AB is 40 root 3 meter, right? So next we move on to the problem number 6. The problem is a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So here we are having a boy and we are having a building, right? So what is the length of the building? You see it is 30 meter. So assume that this is your 30 meter building and here there is a boy standing. Right. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degrees. Right. So at the angle of elevation. So the boy is looking upwards. Right. And the angle varies from 30 to 60. Right. So whenever you see when boy stands here, right, the angle of elevation will be 30 degrees. I'll tell you why. Right. But when the boy moves towards the building, then the angle of elevation gets increased to 60 degrees. Right. So can you tell me why? Why the angle of elevation is increasing? You just try it at home. Right. So you just stand before some building or whatever may be. Right. So when you are standing at a distance, okay, you have to tilt your head a little bit upwards. That is enough to look at the top of the building. But when you move nearer to the building, you have to tilt your head upwards comparatively higher. right? So that is the reason why here it is 30 degree and here it is 60 degree. Whenever you move towards the object, you have to tilt your head in a better way to see the top view, right? To see the top of the building. So that's the reason here why it is 30 degree and here it is 60 degree, right? So find the distance he walked towards the building. So he is standing at a point. From this point, the angle of elevation to the top of the building is 30 degrees. But he moves some distance, right? And in that point, the angle of elevation is 60 degrees. Now we have to calculate the distance traveled by the boy from this point to this point, right? Am I making the question clear? That's the thing. So you see the same diagram I have drawn in a better way, right? That's it. So this is your building, right? And this is the boy, and the height of the boy is 1.5 meter. Initially, and in this position it is 30 degree and in this position it is 60 degree. That's it. We need to find the distance traveled by the boy, and so here it is CD, right? So first we make it clear. You see the total length of the tower is 30 meters, right? So here the length of the boy, that is the height of the boy, is 1.5 meter, right? So you see here it is 1.5. So automatically this side also holds the same value, right? Because you just look at this looks like an rectangle, right? So this side is equal to this side. So here the length is 1.5 meter, right? So how to calculate the length of AB? So this is 30 and this is 1.5. So you have to subtract 1.5 from 30. That is 30 minus 1.5 will give you 28.5. Right. The same thing you see I had written here. The length is AE. Right. So AE is 30 and this AE can be written as AB plus BE. Right. So AB plus BE is 30. So what is the value of BE? It is 1.5. So just substitute here. And the value of AB is 30 minus 1.5, that gives you 28.5. Right. So this 28.5 is nothing but 30 minus 1.5. Then the next thing is, you see, we need to find this distance CD. Right. So to calculate CD, right, first we are starting with this triangle ABC. Then we are going to consider the triangle ABD. Right. So first consider the triangle ABC. So in this triangle, you see, here in this triangle, we know the value of this side, opposite side. We don't know the value of this adjacent side. Right. So here I am finding the value of BC. I'll tell you why we are finding BC. So here you see tan 60 degree is equal to AB by BC, right? So tan 60 is nothing but it is root 3 and the value of AB is 28.5. Just now we have calculated. So from this find the value of BC. So here BC is nothing but, in this case, when you just interchange here, okay, BC here in the denominator, when it is moved to the left hand side, becomes numerator, and root 3 here in the numerator part, when it is moved to right hand side, it occupies the denominator, right? So the value of BC is 28.5 by root 3 meter, right? Now the next thing is, we are going to consider the bigger triangle, that is our triangle A, B and D, right? So again we are going to consider the tan 30, because tan 30 deals with again opposite by adjacent side, right? So what is the thing we need? We need to calculate CD. So here also we are taking tan 30 degrees. So tan 30 is equal to AB by BD, right? So here AB by BD. So the value of tan 30 is 1 by root 3, right? And here the value of AB is 28.5. So here we are calculating BD. So BD is nothing but just cross multiply, right? 1 into BD here and here root 3 into 28.5. So the value of BD is 28.5 root 3 meter, right? So now again look at the diagram. You see we know the value of BD, right? And we know the value of BC. So here we know the value of BD and we know the value of BC. So just to make it more familiar, you see, I am explaining you using simple things, right? So for example, you see, I know BD. Let the length of the BD be some 10, right? And the length of the BC is 4, right? Then what is the value of CD? How can you find the value of CD? You have to subtract, right? So 10 minus 4 will give you 6 here, right? The same way, now I know the value of BD as well as BC, right? Then how to calculate CD? Just you have to subtract, right? So the BD can be written as, okay, BC plus CD, right? So you see, BD can be written as BC plus CD, right? So BD is BC plus CD, but what we need CD. So CD is nothing but BD minus BC. I am moving this BC to the right hand side here, right? So what is the value of BD? It is 28.5 root 3. And what is the value of BC? It is 28.5 by root 3, right? So here in both these terms, 28.5 is common. So I am taking it outside. So what are the remaining terms? Root 3 minus 1 by root 3, right? Again, just take LCM. So when you take LCM, what happens? Here the denominator is 1. I have to make this as root 3. So I am going to multiply both numerator and denominator by root 3. So root 3 into root 3 minus 1 divided by root 3, right? So root 3 into root 3 becomes 3. So 3 minus 1 by root 3. So again here it is 2 by root 3. So 28.5 into 2 is nothing but it is 57. Wait, let me show you that. So 5 2s are 10, right? Remainder 1. 8 2s are 16. 16 plus 1 becomes 17. Again remainder 1. 2 2s are 4. 4 plus 1 becomes 5. So here the point is held after 1 digit. So here it is held after 0. So it is 57, right? So the value of CD is 57 by root 3. Again, since we are having root 3 in the denominator, right, just we are multiplying and dividing by root 3. So when you multiply and divided by root 3, what happens? Root 3 into root 3 becomes 3, right? So 57 divided by 3. So what will be the answer? 57 divided by 3. Here 1 3 is 3, right? And the remainder is 2 and 27. So 9 3s are 27. So here the answer is 19, right? So 57 by 3 is 19 and this root 3 remains as such. So finally the distance walked by the boy is 19 root 3 meters, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.